I've got it.
We are golden now. You should be over here.
I gotta be over here.
All right, yeah, get cozy.
All right, yeah. So we got it's like 2 seats left over here. We got crowd in. It's cool. It's a good group. So I think most everybody in the crowd knows me, but for those who don't, I'm Michael, VP of Engineering here at CloudSpace. Thanks for coming out. Thanks for being part of the community. I get up here every week for most of the folks that have been here, and I give the spiel of what. So what do I say every week when I get up here? Come give presentations, right? If there's something that you want to learn, there's something that gets you excited, there's probably 10 other people sitting around you that are doing that. So come out, give some presentations. Everybody knows Caitlin. Caitlin, just email Caitlin, she'll be happy to do it. This being JavaScript, right?
Yeah.
I think 2 months ago, we did a really fun project where we committed Caitlin to do a project, and we appreciated that. It's almost time to probably do that again. So email me your suggestions, not Caitlin, right? But seriously, email me some suggestions. We'll come up with something fun. We'll have a bit of fun with it. But in all seriousness, thanks for coming out tonight. Caitlin's going to give you all the rundown. She has all the news and happenings and speakers and all of that kind of stuff. I'll be running around behind the scenes. If you guys want to come up, talk, have a quick chat. I always love engaging with the community. So thank you very much and enjoy.
Woohoo. All right. So with the events coming up, obviously we have Orlando Tech next week. And I think we may or may not be still having the pub crawl. I'll keep you guys posted. But Orlando Tech is still going to be at Canvas. For those of you who didn't know, they changed over and UCF is the managing director, I guess I could say, over at Canvas now. So I'm kind of excited to see how that's going to fold out. Also, too, we have, did anybody do Code for Orlando over the weekend? God, there's got to be more hands than that. Come on, guys. I see 2. 3, because I know you. All right. Come on, guys. You got to get out there more.
It was a lot of fun.
Yeah, if you guys want to know about any hackathons or anything like that, I usually have a pretty good heads up on all of it. Sadly, Code for Orlando, their actual meetup does battle with my iOS meetup, but I still encourage you guys to go out there, go help out. I mean, you guys get to work on things that'll help grow the city and help make the city better, which is absolutely exciting. I think a couple people are working on parking apps, which just makes it even better now that they're closing down the parking underneath I-4. So it's pretty exciting. Yeah. But this is a special meetup where I have 2 speakers coming from one company, which is really exciting, which everybody's from Riptide, right over here. Woohoo! So we've been planning this for a couple months now because I have JavaScript booked way months in advance. So I'm excited this is actually happening. And I'd like to start with Tyler. Woohoo! All right, hook that up so that way they can hear you and you can talk about yourself and stuff like that.
Okay, well, I hope the mic right there is all right. Hello, my name is Tyler Dixon. As I was introduced, I work at Riptide Software. I've worked there for about 2 years now, mostly working with JavaScript, and most of the time working with JavaScript, I've been working within the Angular framework. And today what I'm going to tackle is a problem that we've come across many times working with Angular, and that is, hey, I have this super cool JavaScript library that I want to use in my Angular app, but I want all my Angular bindings and I want it to all to be in my normal Angular life cycle. And most of the time that doesn't happen because even here we can go to Bower, type Angular hyphen, and 3,200 results. But every once in a while, you'll hit a case where maybe something isn't quite exactly what you need in an Angular module. Maybe sometimes you think it isn't very well written and you could optimize it. Well, what I want to go over today is basically how to take some sort of generic JavaScript library and turn it into an Angular directive. Or really what you're doing is writing a directive that consumes this library. All right, so what I'm going to do is I'm going to go ahead for us, and what we have here is just decided to choose a random example. We have Slick. Slick is a JavaScript library that lets you super simply set up carousels. And like pretty much every JavaScript library out there, it has an entire cavalcade of options that you could not even ever wish to get to use. So what I have here is I've already scaffolded out an Angular app, and I already have everything set up so that we can just get into it and write the directive. So if you can't tell already, sorry, this might be a little specific to Angular and how it works. But even if you're new to Angular and trying to learn it, I'm hoping to explain directives, probably the most complex idea in Angular, in a simple way such that you can understand it. If you have any questions along the way, please raise your hand, throw something at me, anything to get my attention, because chances are someone else around you has the same question. So, any questions yet? Beautiful. So, getting into it, let's, like any Angular component, let's go ahead and start with our directive. Best practices usually with your directives, prefix it in some way, preferably not ng, because that will probably make the Angular team not very happy. And let's go ahead, prefix td Tyler Dixon Slick. Now, before we start, we see here, like I said before, this library has an extensive amount of options. Let's go ahead and just scope ourselves in real fast. And what I'm going to write is I want a directive that essentially does what you see right here. Is this text large enough for everyone? Anyone want me to bump it up a little bit in the back? Bump it up. There we go, beautiful. So what we're going to do with our directive is our hope is to have a beautiful td slick directive. What we should be able to do is with our slick options, pass in all of the options that we can when normally initializing this library. With our slides to show and speed attributes, what we want to be able to do is define these attributes dynamically and update our directive as they change. And then finally, our beautiful Slick library has a set of events we can listen to. So let's just go ahead and set up, they have a after change event. Let's go ahead and set up a function to be called when that event fires. So getting into it. So when starting with the directive, the first thing that's going to come across is the restrict property. And restrict can either be set to A, E, or C. What that means is it can either be an element, td slick, it can be an attribute, or it can be a class. Now, each of these has their own use case. For example, you want to use element when you're creating a directive that is going to directly manipulate the DOM, extensively directly manipulate its children, etc., etc. Attribute is something that you want to use when you just want to decorate the functionality of an element. So let's say you want an element on hover to play Miley Cyrus's Party in the USA. You would use an attribute for that. And class should not exist. There is absolutely no reason for you to probably ever define an Angular directive with a class. Even in the documentation, they have a little tidbit, should I use an attribute or a directive? Never again do they mention, oh yeah, the use case for class is this obscure one. So just don't. So what we're going to do in this case is we are creating something that is going to directly manipulate the DOM and its children. So we're going to go ahead and set up set it up as an element. So what you can do, the next property you'll typically define in the directive is your scope. And in Angular, scope is essentially how you typically interact with DOM elements. You want to set an item in your scope, and typically you'll set up elements so that it checks these, it watches them for updates, and whenever it updates, it should update the DOM accordingly. So in our case, what we need to pass to our directive is first off, slick options. So up here at the top, we have slick options. We want to pass that in, and now I have this. So when passing items from the parent scope to your directive, you can do it one of three ways. First, an equal sign. This is your usual use case. This will set up two-way binding. So now whenever slick options changes, what we will see is if we watch this value in our directive, whenever something else in our app changes slick options, we'll go, hey, we should do something about that. So we'll do an equal. Slides to show, we'll do the same thing. Speed, the same. So next we have our after change. We see that with this, what we're going to want to do is evaluate an expression whenever our library raises the event after change. So here we have after change, and we'll set that up with an ampersand. What an ampersand does is it allows you to evaluate an expression in the context of its parent scope. And what that essentially boils down to is you want to be able to take, let's say in your controller, you define ASDF to equal the string ASDF. Well, now this directive, when evaluating this expression, will properly pass ASDF to your controller function. So that's it for our scope, and next, you hit the point where you can either use a compile function or a link function to set up your directive. The compile function is if you want to manipulate your template in some way before you set up your bindings. And in this case, we don't really need to do any manipulation. All we need is just to set this up. So we're going to opt for the link function. The link function, you pass scope, element, and attribute, maybe in that order. Let me check my cheat sheet. Scope, element, attribute. Beautiful. So now we have a function set up, and now we can start actually working with our JavaScript library that we have and set up all of our bindings as we need. So first thing we need to do is we need to, from our parent scope, grab our slick options. That is as simple as, so what you can see here now is that the slick options that we defined above, we can now access in the scope of our directive. So now, when using this directive here with slick options arrows true dots true, we will now have that object saved in options in our directive. Next, we need to bring in the attribute options if they are set. So at time of initializing your directive, if slides to show is set or speed is set, we want to go ahead and make sure that we get those options in before we initialize our library. So what we can do is if scope.slides to show, so we want to make sure that if this is defined, we're going to set options dot slides to show equal to scope dot slides to show. And we are going to go ahead and do that same exact thing for speed. So now when we initialize our library, we have the options that were passed in via slick options. We have slides to show in speed, which were passed in through their respected attributes. So now we can get to the point where we're actually going to initialize our library. Any questions so far?
You have an extra parentheses. I think. Just making that question.
Thank you. Okay. And then I'm a good developer, as you can see. So what I want to do now is I want to initialize our library. So usage, beautiful. We can take our element, call slick on it, and bam, we've got ourselves a slick library. So we wrap our element in jQuery, call slick with our options, and bam. We refresh. Naturally. We refresh, and it is broken because at this point, when we are setting up our directive, if we look at the template, the way I have it set up is inside our directive, we just have an ng repeat 1, 2, 3. It'll just print out 3 divs that have the content 1, 2, 3, and 4 divs. So what's happening here is our directive is initializing the library prior to ng repeat finishing compiling the DOM and rendering it. So what are we going to do in this case? There's one of 2 options that we can take. First, we could wrap this initialization in a timeout. And what that does is it's essentially saying, yeah, next time the browser has a chance, take some stuff and do it. We don't want to be that inexplicit. What we want to do is we want to allow our children to say, hey, I'm part of that carousel. So what we need to do is, looking at this template, we need to set this up as a td slick item. We need to now create a directive that communicates with our parent directive and manually adds itself to the carousel. So time for directive number 2, td slick item. And now we're pretty much going to take the same course of action, return an object that is the configuration of our directive. First thing we can do, the restrict that I talked about earlier. This time, since we're just enhancing the functionality of a single element as opposed to manipulating that element in some way, let's just set it up as an attribute. I don't think there's anything we're going to need from the scope, but it's always good practice to create an isolated scope for your directive so that you don't start accidentally making some assumptions about your parent's scope. And then again, our link function. So now we need to take this and we need to add it to our parent element. But we have, outside of using document, we can't tell who our parent is, and we shouldn't do that. We should allow inside Angular a way that we can communicate to our parent directive. And the way we're going to do that is we are going to set up a controller for our directive. What this allows us to do is now our parent directive, td slick controller, now our parent directive can attach this element to the parent scope. So if we do td slick controller dot element equals Ella. Now this controller has an item in its scope called element that points to our initialized slick. So if we go down here, what we can do is we can define require We can do this to define we require something in our parent. We require the td_slick directive as our parent with a controller. Now again, we can use the td_slick controller, and let's go ahead add item. Slick add. So td_slick dot element dot slick add element. Now our child directive will properly add itself to the carousel. So let's go ahead over to this. As expected, fn is not a function, got object. So we are going to hit the break glass in case of emergency, and we are going to now, instead of slick1, we are going to pass in our working directive, and we will take it from there. So as we can see in the very properly working directive, same functionality, but without whatever typo. So now we go ahead and refresh this page, and holy wow, we have a carousel that works. Look at how pretty that is. I'm the best web designer ever. Look at that. Okay, so now let's pretend the rest didn't happen and that we've hit this point where now we need to make it so that our directive properly watches the parent scope and sets, and now let's say slides to show or speed change in the parent scope in some way. Well, what we can do
initial state. Then you render your state. And the beauty of this is that you render a XML, it's an XML-like syntax that renders a view and outputs it to your screen. Whenever you want to change, you simply bind any handler to the select function, and it will set the state. The action of setting the state will call React to render. And this render is going to render the entire view. So you don't think of, let me incrementally change this element in here because somebody clicked. Let me change this text. Let me change. You don't do that. What you do is you get your current state and you render the entire thing, all of it. And you let React figure out what the mutations need to be on your DOM in order to get your state to what you need. So the first component is the palette, and the second component is the chalk. So now we get to combine both. And when I render an item, what you can see is I have a chalk. So I'm sorry, I have on my palette, which has multiple chalks, and I'm going to, in JavaScript, simply iterate and return the chalk that I need. So here's my map function. So I get my color options, I call a map, I calculate my offset so it'll lay out where I need it to be, and I return the chalk. Now this is very unintuitive if you're coming from an MVC or MVVM, where everything is very decoupled, and then you have a controller, and then you have views that bind to it, that have two-way binding and overlay, and this is not that, right? The purpose of this is to keep it simple. It's for if you have a view that you know how it's going to look, you always want it to look the same way, you're working on a single product, you're not going to...
Is it supposed to be position in Word?
It is, thank you for that. But because I spelled it wrong everywhere, it works right. But yeah, it is supposed to be. Copy paste is awesome, sometimes. So in this case, we have a specific view that we want. We're not really looking for reusability. What we're looking for is simplicity. So you have to think about when you're developing what you're looking for. You're looking at something simple or something incredibly configurable, which is obviously inherently more complex. Okay, so now what we do is we will call chalk. I will render my SVG. I'll pass in all my chalks. And what it does is it's going to go ahead and render. So here's my chalk, which is a circle, and it sets everything. I don't want to get into the details of React. There's plenty of tutorials online. But the point that I do want to get across is that just like any function of programming, your input is your current state of your application, or specifically the state of the application that this component cares about, and the output is that rendered view. So what we have now is this piece up here. The next part's a little bit, it's significantly more complex, which is what happens as you draw and how to keep this in sync. And there are quite a few tools that you can use. And let's go through them. Are there any questions up to now? No? All right, this is the chalkboard. The chalkboard is a little bit more complex because the chalkboard tries to synchronize and tries to keep up to date with the user as he's pressing and he's dragging the mouse around. But remember initially when I said we have to keep track of the state, when the mouse is down, when it's up, what do you do? With functional programming, you don't have to keep state, because what you can do is, instead of keeping track of state, you can simply execute what function you need depending on your state. Instead of having an if true, then check it somewhere else, set it to false, and iteratively. So let me go through this and I'll explain. So the first thing that we do is we get our initial state, which I need the height, and I need all the paths that are available. In React, it gives me a callback when the component is mounted. Like I said earlier, React writes your output to a virtual DOM. That virtual DOM is then emitted onto the actual DOM. So this gets fired when the DOM has written that element, and that's what we want to bind to. So what I do is we get the node, we find the node that this is bound to, and we'll get back to these methods earlier. So earlier I spoke about functional reactive programming. So in functional programming, such as React, I have an input, my state, I get my output, which is my rendered view. In functional reactive programming, you think of everything as a stream of data, an ongoing stream of data. That's very similar to events and what we have in the DOM. We have streams of user data that's constantly coming at us. They don't stop. We don't know when you're going to get it. So it's nice to be able to normalize this into one stream, and then we can perform actions on that one stream. So here's what we can do. I want to create an event from my node on mouse down. I want to map it to prevent default. So all it's going to do is going to take that event, it's going to execute prevent default, it's going to return that event. Let's go take a look at it. It's very simple. So here it is. prevent default. Yep, this is wrong. And he returns it. The next thing I want to do is left mouse button. So I want to make sure that the left mouse button is selected. So what I do is I run it through a filter. And I filter, make sure that the left mouse button is clicked. We do the same thing for the mouse up. And we have the mouse move. Now, we do the same thing, same pattern that we're doing. I want to create multiple streams. So in this case, we have 3 streams going: mouse up, mouse down, and mouse move. With the mouse move stream, though, we're going to map it. We're going to filter it, same exact thing. This is redundant. But here, when I map it, what I'm going to do is I'm going to map it, and I'm going to return the X and Y position with the offset of where the board lies, because that's all I really care about. I don't care about anything else on that item. So, how does this work? Now that we have these streams, these are unobservable streams, we're able to bind or subscribe to changes on these streams. So, it's as easy as I want to subscribe to the mouse down source. Then what I want to do is I want to subscribe to the mouse move. So this is an example of me using the functions to set myself in the scenario where I'm ready to listen to mouse move events. There is no if clicked, if not clicked. It's very, very simple. Same thing on the mouse up. I now subscribe to this, and I'm able to go ahead and dispose. So by disposing my subscription, I know I'm no longer listening or subscribing to mouse move events, making my code extremely simple and very, very easy to augment because I can keep binding to more and more functions. Okay, so in the case of the board, which is the most complicated piece, we have the render function. And in the render function, what I'm able to do is we have specific the lines that we want to draw. And all we do is we return the SVG, which is going to pass in lines. So it actually creates the lines that I want. It passes in the color that I've chosen. It's passed in the points that I want. And it will render a path. It'll set the stroke, and it will set up all my points. So if you think about what we've done here, we've taken a stream of inputs. We've converted that stream of inputs into a state for React that converts that stream of inputs into views. That calls another view to draw the lines. And we're able to change the state when we detect that someone has drawn, and everything will get rendered for us. And in the case of React, it will take care of that DOM manipulation. So it really eases the complexity. The next part is how we manage the complexity of synchronization. Now, when I was going through this, I did not do this functionally. I wanted to go ahead and kind of separate the concept of a domain object, which is the array of paths and all the points that everyone has drawn, and update them incrementally. And by doing this, I really learned to appreciate how easy functional programming could be. So I'm going to go through this as well. So in this case, we're using socket.io. If you haven't used socket.io, it's a great tool for keeping all your data in sync. So the first thing that we do is we create, this is our draw namespace, and we create an observable. basically the views are React. Anything that is observed upon when I change or add a path or add a dot, it'll automatically draw and render for me. So I have a socket, and what I want to do is I want to get my paths, and it returns my data for me. Then I start adding my helper methods, which will add a path, and it'll emit to socket.io the path. I'm able to add points to my path, and that'll do the same thing. It'll emit my points to my path. And I'm able to bind to when a path gets added and when to a point on a path. So a path would be a line, and every point would be every point on the line as I'm drawing. So the reason that this works, and you're able to go through both browsers, and it's simple and it's not complex. Well, there's not a lot of line of code, but it's really not that complex, is because part of functional programming is to have an acyclic loop. So if you notice, we have all our bindings are one way. When we draw on the board, I add a path. This path sends a socket communication, and my draw listens for those events. It gets that event and then it renders. It seems wasteful, but it makes it very, very simple, because what we're doing is we're going from the source, being the user, down to the server, and then back up to the UI that renders it out. So there is no word, I don't have to worry about any concurrency, any type of management. It's very, very simple, and everything is one directional. Are there any questions? It's got to be a lot.
Really? Don't be so quiet, guys.
Yeah?
I wouldn't even know where to begin. Honestly.
Pick something.
How's the performance of this? Because it's going to render everything?
That's a great question. So React takes care of that for you. So what React.js does is every time you render an output, a view, it goes to a virtual DOM. It's basically, it's in memory. It's in JavaScript. It's not in the actual DOM. So React takes care of making sure that you're not under any kind of heavy load, and it will compute the minimum amount of DOM manipulations that it needs to get your view up to date with the virtual DOM.
So React handles that.
So React handles that. And one of the nice things is, because you're going to a virtual DOM and not an actual DOM, the team at React.js have actually taken that virtual DOM and output it to native control. So there's a React for native iOS, there's one for Android, they're even right out to Canvas.
So
React
this is a
also
binary.
can
This is actually
destroy the garbage collection events that are canceled, or usually the event that doesn't finish the very.
Well, this is actually much simpler, because I'm glad you brought that up. So in a program where in a program that you're always manipulating the DOM, right? Or a domain object, you bind to an event when someone clicks, then you unregister, then you go ahead and change something else, and you bind to that event, then you unregister. In this case, you notice that there was no unregistration, because I always want to know when someone's going to draw. I want to know when mouse down or mouse up. So what I do is I have one stream of that event, and what you can do is you can funnel all those events into that one stream. So I don't really have to unbind, because I always want to know.
Thank you.
Any other question?
Yeah, I think you kind of answered it. So React doesn't. What I was getting is that React basically replicates the DOM, but using.
Correct. And the reason it needs to replicate the DOM is, so think of how a graphics card works, right? So if you have a graphics card and you're rendering, and you have a video game and you render a video, what does it? Renders the entire video, right? It doesn't just change the avatar that's walking, the entire screen changes.
Right.
That's another functional language. That's another way of functional programming, right? Where here's my state, here's my video state, render my avatar, actually render the entire map. So that's the same concept with React. You refresh every single time your state changes. But because refreshing and rewriting your DOM is very, very expensive, they have an intermediate layer where what you're writing to is a virtual DOM, And then what React is doing is calculating the amount of mutations that they need, the minimal amount of mutations, so you can update
So
your
it
view.
just updates exactly what needs to be
Correct.
actually changed in the DOM.
Correct.
Okay, that's all right. That was the part that I was fuzzy on.
Sure. Question?
Will you be throwing this up on GitHub at all?
Yes, it's it's a public repository.
Oh.
It's already available. You can download it, check it out, run it, play with it.
Another question. Now you said before that React has one of these rendering objects
Sure,
for
so-
every for
Ev-
every different platform.
Yeah, correct.
So if I were to this isn't pure JavaScript.
This is pure JavaScript because React is a JavaScript framework. Now the difference is that there's an interpreter that knows how to interpret JavaScript and convert that element instead of, let's say, into an input. It can do it to iOS input tag or Android.
I know Chrome does the V8 engine does that.
That's completely different. React that's different than React, because what React is doing
Right.
is using JavaScript to interpret the view that you want,
Right.
and then taking that view and interpreting it to whatever platform you're on. So by default, you're on web. Therefore, it would
Right.
use the V8 engine and output the view as an element. If you're on another platform, they have a toolkit which will take that JavaScript, it's still running JavaScript, to
Right.
represent it virtually, but the actual output would be a native controller in whatever platform you're in.
Okay. All right.
Every time I've heard React, it always seems to be paired with Flux. I mean, are they two separate libraries, or do you
So-
usually use one with the other?
I'm very glad you asked that. I didn't do a very good job of explaining this part, so I'm gonna try again. When writing this application, all the events, all the user events, were channeled into this draw, this core library. It went in one direction. From here, the events were dispatched using socket.io down to the server, which would update the domain object and then emit the events back to the UI that would then go ahead and draw. Seems like a big round trip, but you saw how fast it was working. That concept is what's called an acyclic graph, where the data flows in only one direction. There are no two-way bindings. So what Flux does, it gives you that same ability to where instead of binding to an object, and when it changes you do something, your view puts an action onto Flux. Flux will say, okay, he wants to do this. Let me dispatch it to the view that's supposed to perform that action. It will then change the state of the component. It'll re-render, and then that view component, if it wants to, can put another action in. But you can only process one action at a time. Same with this. There's really only one input going on at a time. It's just going very fast, so you can see it moving. So Flux is kind of is a pattern to follow with functional programming, where you're only doing one thing at one time. Any other questions? Yeah.
Sorry, I'm wrong. If you have an application with a lot of users doing things asynchronously at the same time, and React keeps rendering the page over and over again, is it just doing it on a per user basis, or is it doing it for everyone at the same time?
So React, you can do React both server side and client side. This case, it's all client side. So every client just gets updated. So you just have to manage concurrency with your domain object in your server. Yeah. Any other questions? Cool. We'll stop raining, so I think we're good.
Alright. So those tickets do have a reason. Let's hope my laptop cooperates. And I'm gonna stop streaming as well because I'm not having another rerun of that. Sorry guys.